Today we're going to work with simple machines. It's PS 10, C, and D, simple machines and mechanical advantage. So let's take a look here. So what does simple machines do? Simply put, it's a machine is any device that people or helps people do work by changing the way work is done. There are 6 different common simple machines. The 6 types of simple machines are levers, wheels and axles, pulleys, inclined plane, wedges, and screws. We're going to talk about several different simple machines in the next couple lessons here. And the first thing I want to talk about is the different forces that are put on a machine. So here is an elephant, okay, being lifted up by the pulley, and a person pulling down on a rope. Okay, there are 2 different types of forces. Okay. The first one is the input force, and that is the force when you're pulling down on a rope. The input force, you're putting it into the machine. The output force is the force that the machine is exerted, or the force the machine exerts on the object. Okay, it's the elephant being lifted up. Okay. So, real quick to recap, work is done only when a force is applied and some type of object moves. So if I input force here on the pulley, the output force is the elephant lifting up. Right, here is a simple machine. It's a lever. There's 2 different types of levers here. And the input force on a bottle opener is me lifting up on this end, and the actual bottle cap being pried open is the output force. On a hammer, if you swing the hammer at the bottom, that's the input force, and then at the top, the hammer head hitting the nail is the output force. Okay. So bottle openers and hammers are examples of simple machines. So continuing what simple machines do, we said work equals force times distance. So a simple machine, if you apply less force with the machine, you're going to do that over a longer distance. There's a trade-off here. Okay? The amount of work always stays the same in a machine or a simple machine, but if you do less force, you're going to do that over a longer distance. Okay? So some machines decrease the size of or the amount of the force needed. However, you apply that force through a longer distance. While other machines might increase the amount of force needed, but you're going to do it over a shorter distance. So I always try to use the example of a ramp, okay, or when you're loading a truck. So when you load the truck, okay, if you pick the box and you put it directly on the truck, it takes a lot of force, but you do it over a short distance. Or you could take that same box or object and put a ramp on a truck and slide it up the ramp. When you slide it up the ramp, it takes less force. It's easier to do, but you have to do it over a longer distance. Okay? So simple machines make work easier. They don't make less work. And so here's a lady who's using a lever, okay, to lift the rock or the load up. Okay, so real quick, machines change the way you do work by changing the direction of the force. She's going to push down, and the rock or the load is going to go up. Okay. Some machines can change the direction of the force, some might change the amount of the force, and some might even change the distance through which the force is applied. For this example, she's pulling down. It's going to take less force, less input force, because the length of the lever arm is so long. So she can move this large rock with less force, but she has to have a nice long lever arm. So let's talk about mechanical advantage now. A machine's mechanical advantage is the number of times the machine multiplies the input force. Mechanical advantage is a way of comparing the input force with the output force. I have over here a set of pulleys, 3 pulleys, and this 100-pound load right here is what you're trying to lift. Now 100 pounds is hard to lift by yourself, but if you use a series of pulleys, the effort or the input force would only be 25 pounds. Okay? So you can easily calculate this, okay, by dividing the output force by the input force. So the formula for mechanical advantage is output force divided by input force. So if I have this pulley system and I have 100 pounds, that's my output force. So 100, okay, divided by 25. Okay, so 100 divided by 25 is 4. The mechanical advantage is 4. So of this pulley system, the mechanical advantage would be 4. That means the effort force or the input force is multiplied 4 times to lift that 100-pound load. Alright, so real quick, mechanical advantage, there's a formula, force output divided by force input. Okay, and if a machine has a mechanical advantage greater than 1, the task seems easier. The output force is greater than the input force. So anything greater than 1, the machine makes it seem easier. Okay. If it's equal to 1, you're only changing the direction. You're not, you haven't gained any, it didn't make work easier. You haven't gained any easier way of doing that work. Okay. And if it's less than 1, you have to put more force. It means greater force over a shorter distance. Okay, so less than 1, you're going to put more force. You're going to need a greater distance. Okay, so let's finish up mechanical advantage. Okay, the last part of mechanical advantage is mechanical efficiency. Okay, and it is a way we compare a machine's work output with the work input. So efficiency equals work output divided by work input. Same as mechanical advantage, but we're talking about work and not the force. Ideally, okay, the work of a machine does not that does on an object is the same as the work that you put into it. So in the perfect machine, the work that goes in is the same amount of work that comes out. But in the real world, we have to deal with friction. Okay, so in the real world, all machines, their input work is always going to be greater than their output work. And we lose a lot of energy to friction and heat. So think of a car. A car gives off a lot of heat. It doesn't use all that energy that's stored in the gasoline because some of the energy goes into the turning the engine, turning the belts, and causes heat and friction. So we lose energy in every machine. Only the perfect machines, okay, will have a mechanical efficiency of 100%. So here's a real quick exit ticket that we might do, and if you haven't done it, you can do it on your paper. Okay, a student wants to find which machine has the greatest mechanical advantage. Machine 1 has an output force of 90 newtons and an input force of 35 newtons. Machine 2 has an output force of 105 newtons and an input force of 75 newtons. I would like you guys to calculate that, see which machine has the greatest mechanical advantage. Be ready for this when you come in next class.